Hello everyone, my name is Ida and I'm going to be talking about periodic table of elements, protons, neutrons, and electrons. Here's a periodic table of elements. I want to talk about how important this tool is. It gives us a lot of information. I want to discuss that every column is called a group, so we have 18 groups, and they're either from 1A to 8A, and then in the middle the transitions are your B, or you can just go from 1 through 18 straight right across. They mean the same thing. Anything that's a row is called your period, so you have a total of 7 periods. Just pay attention to how these elements are classified in terms of metals, nonmetals, halogens, noble gases. I'm not going to really read the chart for you, just talking about a better sense of what it is. I want to talk about different charges. So anything in group 1 is a +1 charge. Anything in group 2 is a +2 charge. Anything in group 5A or group 15 is a -3 charge. Anything in group 16 or 6A is a -2 charge. Anything in group 17 or group 7A is a -1 charge. Those charges will come into significance when we learn ions, nomenclature of chemical formulas, and all of that stuff. But this is a good start to understand what the periodic table is. So I want to take some time to understand the symbol on our periodic table. The first number here is our atomic number. This is our symbol for germanium, G, capital G, lowercase e. Germanium is our element's name, and our last number here is our mass number. Mass number is also synonymous to molar mass, also atomic mass units. Alright, so real quick, if you have a periodic table, have that right next to you. Let's do the symbol for sodium. Sodium is Na. Na has an atomic number of 11. We're going to write sodium on the bottom. And our mass number for sodium is 23. And that's what we want to understand on this slide. The atom. The atom consists of a nucleus, and inside this nucleus you have protons and neutrons. Protons are positively charged particles. Neutrons are neutral, so 0 charge. And orbiting this nucleus, you have electron orbitals. 1, 2, 3, and so on. And you have electrons floating around. And so on. Every orbital has its maximum capacity of electrons. And the way we can figure that out is utilizing our formula of 2n squared. Will give you your maximum number of electrons each orbital can occupy. So let's calculate some things. If you have your orbital number, so what orbital? N, and then the maximum electrons that it could hold. If n is 1, if we plug it into this formula, you get 2. If n is 2 and you plug it into this formula, you get 8. If n is 3 and you plug it into the formula, you get 18. If n is 4, you get 32. So what this is saying is that this first orbital right here can only hold 2 electrons. The second one right here can hold up to 8, nothing more than 8. The third one can hold up to 32. So that's how you deal with the orbitals and how many electrons it can occupy. So now we're going to determine the number of protons, electrons, and neutrons in the following elements. But before I go over that, we need to understand the relationship between an atomic number and the mass number and how we can utilize that to solve for our protons, electrons, and neutrons. So the first thing is write the chemical symbol for oxygen. So oxygen has an atomic number of 8 and it has a mass number of 16. And that's oxygen. So if I want to figure out the number of protons, that means that it's going to be the same as your atomic number. So your atomic number is equal to the number of protons, P+, and the number of electrons. Okay, so for oxygen we have 8 protons and 8 electrons. Now the mass number will help us figure out the number of neutrons. So for oxygen, our mass number is 16. So the number of neutrons is equal to the mass number minus our atomic number. And that's the relationship we should know. So our neutrons for our oxygen is 16 minus 8, which is 8. Alright, so let's do xenon. And our atomic number here is 54, and our mass number is 131. So our protons and electrons are the same as your atomic number of 54. But our neutrons is the difference. So our mass number, so neutrons is mass number 131 minus our atomic number of 54. We get 77. And then the last one, if we do ZR, its atomic number is 40 and our mass number is 91. You know that the neutrons are going to be 91 minus 40, which is 51. And obviously, we know that our protons and electrons are the same as your atomic number, so that's going to be 40. Now what I'd like to do is to determine the protons, electrons, and neutrons for these different ions. Remember, we have cations and anions. Cations are anything that will be a positive charge, and anions are anything that are negatively charged. Positive means you're losing electrons. Negative means you are gaining. It's just opposite from math. Cations is positive, you're losing electrons. Anions is negative, you're gaining electrons. So, for example, for oxygen with a -2 charge, nitrogen with a -3 charge, sodium with a +1, and magnesium with a +2. Oxygen and nitrogen are anions because they're negatively charged, so they're gaining electrons. Sodium and magnesium are cations because they're positive charged and they're losing electrons. So I would like you guys to use your periodic table to fill in your atomic number and mass number for oxygen, nitrogen, sodium, and magnesium, and I will do that as well. Okay, so now the number of protons will never, ever, ever change whether it's in its cation form or its anion form. So, like we just learned from our previous slide, our atomic number is the same. Our atomic number is equal to the number of protons, right? P plus. So our protons are going to be the same as your atomic number. 8, 7, 11, and 12. Now our neutrons are going to be mass number minus electrons. We just, mass number minus atomic number. So our neutrons is equal to mass number minus atomic number. So let's do that. Neutrons will be in blue. So our mass number for oxygen is 16. We'll do oxygen here. 16 minus our atomic number is 8, so we get neutrons of 8. Nitrogen is going to be 14 minus 7, so a total of 7. Sodium is going to be 23 minus 11, so you end up getting 12. And magnesium is 24 minus 12, which is 12. Alright. Now the number of electrons this time is not the same as your atomic number. The electrons are basically going to be based upon your charge that you see here. So, let's pick another color for our electrons. We'll use purple. Alright, so our electrons are going to be, if oxygen is a -2 charge, -2 we just said was a cation. Is an anion, I'm sorry. If oxygen -2 is an anion, that means it's going to be a negative charge, which is an anion. And an anion basically means it's going to gain electrons. So if it's a -2 charge, it's going to gain 2 electrons. Okay, so we're basically going to say we're going to gain 2 electrons, so it's going to be gaining from this number. So 8 plus 2 is 10, right? Now if we look at nitrogen with a -3, that means it's going to gain 3 electrons. So if you gain 3 electrons, so 7 plus 3 is 10. If we look at sodium plus 1, that means it's a positive charge, so it's a cation. And look at this. Cation, you can remember, is because it's a big plus sign in the between. That T looks like a plus sign, so it's a cation with a positive charge. So if it's a cation, then it's going to lose electrons. So sodium, because it's plus 1, it's going to lose 1. So it's going to be 10. And then if you have magnesium plus, you're going to have magnesium plus 2. What does that mean? You're going to lose 2 electrons. So if you're going to lose 2 electrons, 12 minus 2 is 10. So you can understand that Protons never ever change. If you change the number of protons, you are changing that atom. Electrons change because in ions, you're either losing or gaining electrons. And the neutrons, that basically is the same from the previous slide where we utilize this formula. So this is a try on your own slide. I made this chart. You basically have to fill in the ones that are missing using what you learned today. And I just want to point out that over here this is K plus, which is a cation, and this is S to the -2 power, like this, which is an anion. I would pause the video now, try it on your own, and then I will put up the answers. So here are your answers. I hope that you understand how to get it. If you do not, please go back and review the material. Remember that practice always makes perfect.